Hello everyone, today we want to solve this equation and find x and y. In this question, x and y need to be a positive integer. There are two possibilities for x and y. One is x greater than y, and the other one is x is lower than y. Since this equation is symmetric for x and y, if we solve one of these assumptions, we will have the answer for the other one too, because as you see, we can exchange x and y with each other. It doesn't matter. For the first assumption, x is greater than y, since x is greater than y, 1 over y is going to be greater than 1 over x. So we can write 1 over x plus 1 over y lower than 1 over y plus 1 over y. We exchange x and y here by each other, and we know this one is 1 over y is greater than 1 over x. The left-hand side is our main equation, so it's equals to 1 over 5. And the right-hand side is 2 over y. So from here, we can find out y needs to be less than 10, less or equal than 10. So now we found the upper bound for y. Let's go and see if we can find the lower bound too. So this is our main equation. From our main equation, if we multiply all of the elements, both parts, to 5xy, we will have 5y here, 5x here, and xy here. We multiply both sides at 5xy. Now we can subtract xy from both sides, and we will factor x here. So we will have 5y, which is here, and 5x minus xy, and we factor x here. Now we can write x based on y. So in the first assumption, which x greater than y, we found y needs to be less than 10, and we found that x equals 5y over y minus 5, and x and y need to be positive integers. By the assumption of the positive integers, now we want to simplify this one and see what possibility x and y have in this equation. So x needs to be positive integers, so both parts of this fraction needs to be positive, or both parts needs to be negative. And we know that y cannot be negative because it's greater than 0, because it is positive integer, and it cannot be 0 too. And so y minus 5 needs to be positive. So this is going to be like this. So from the previous slide, we found that 5 needs to be greater than 6 because 5 minus 5 needs to be positive, needs to be greater or equal 1. So y is greater or equals to 6. Great. Here we found the lower bound, and we found from the beginning the upper bound of y. So y only have 5 possibilities: 6, 7, 8, 9, and 10. So we can find x from that. Let's go through each of the possibilities. Now y equals 6 and x equals 5y over 5. If we put y equals 6 here, we will have x equals 30. So both of them are in positive integer, and x is greater than y. So that is correct. The other one is y equals 7. If we put in the equation that we have, x is going to be 35 over 2, which is not correct because it's not integer. And again, 8 is going to be 40 over 3, which is not integer. And then 9, 45 over 4 is not integer again. And then if y equals 10, x will be 10. So this is great because, again, x greater or equal to y, and both of them are positive integers. So on this condition, only two possibilities can happen. These two. So we solved everything for the first assumption, which was x greater than y. Now we want to go through x lower than y. So again, everything is the same, but x and y is going to be different. So everywhere that we had y is going to be x, and everywhere that we have x is going to be y. So if x is equals 6, y is going to be 30, and again, 7, 8, and 9 are not acceptable because they are not integers, and 10, again, y is going to be 10. So we have three possibilities: x equals 6, y equals 30, or x equals 30, y equals 6, and x and y equals 10. So these are the answers for our equation. Thank you for watching us. I hope this video was helpful for you, and see you soon.